Dr. Pankaj, can you hear us? Good afternoon, Dr. Santosh Kumar. Yes, yes. Pankaj, we could see you on the screen. Can you hear us?
Good afternoon. Good
Yes, sir.
afternoon, sir.
Good afternoon, good afternoon. Dr. Pankaj, can we start?
Yes, sir.
Yes, yes. Sunil Garu, please proceed,
Yeah.
sir, because Sir has early joined.
Yeah.
Please.
So, Dr.
I am.
Pankaj Dadheech, sir, good afternoon, sir.
Yes, sir. Good afternoon.
Sir, we, the Department of CSC, Sri Vishnu Engineering College for Women, Bhimavaram, we cordially invite you to this faculty development program as a resource person, sir. So, despite of your busy schedule, you gave your valuable time to share your knowledge with our participants. First of all, really, we are thankful to you, sir. Before entering to the session, let me take the privilege to introduce you, sir. It is my great honor to introduce Dr. Pankaj Dadheech. Dr. Pankaj completed his PhD degree in computer science and engineering from Suresh Gyan Vihar University, accredited by NAC with A grade, Jaipur, Rajasthan. He completed his MTech degree in computer science and engineering from Rajasthan Technical University, Kota, and he has completed his BE in computer science and engineering from University of Rajasthan, Jaipur. He has more than 16 years of experience in teaching. He is currently working as an associate professor and deputy head in the Department of Computer Science and Engineering, Swami Keshavanand Institute of Technology, Management and Gramothan, Jaipur, Rajasthan, India. He has published 21 patents and granted 4 patents at Intellectual Property India, Office of the Controller General of Patents, Design and Trademarks, Department of Industrial Policy and Promotion, Ministry of Commerce and Industry, Government of India. He has published and granted 4 Australian patents at the Commissioner of Patents, Intellectual Property, Australia, Australian Government. He has published and granted 1 German patent. He has also registered and granted 2 research copyrights at Registrar of Copyright, Copyright Office, Department of Promotion of Industry and Internal Trade, Ministry of Commerce and Industry, Government of India. He has presented 53 papers in various national and international conferences. He has 58 publications in various international and national journals. He has published 5 books and 11 book chapters. He is a member of many professional organizations like IEEE, Computer Society, CSI, ACM, IAENG, and ISTE. He has been appointed as a PhD research supervisor in the Department of Computer Science and Engineering at SKIT, Jaipur. He has also guided various MTech research scholars. He has chaired technical sessions in various international conferences and contributed as a resource person in various FDPs, workshops, STTPs, and conferences. His area of interest include high performance computing, cloud computing, information security, big data analytics, intellectual property right, and Internet of Things. So really, all our participants are very lucky to have a great person like you as a resource person for this faculty development program, sir. So now I request you to enlighten us on the topic of an approach for performance analysis using big data analytics. Now the platform is yours.
Yes. Thank you, sir. Thank you, Dr. Kiran Sri Papulari, and thanks for giving me this great opportunity. Today, I will take the session on big data. So, I am sharing my PPT. it visible, sir?
Yes, yes. Your slides are visible and you're audible. Please proceed, sir. Thank you.
Okay, sir. So today we will discuss about big data analytics with Apache Hadoop. So in today's scenario, you can see everything is about data. So can you imagine in a minute or in a second how much data is generated day by day? So around 2 million searches in a minute on a Google, or 14 new songs added on Spotify, 70 new domains registered, and 15,000 tracks downloaded from iTunes. Like you can see, this is the about data. So around 36 hundred photos every second is uploaded on Instagram, or you can see the Flickr 20 million photos used on Flickr, or 41,000 photos every post every second on Facebook. So this is all about data. So data is just the raw facts and the information in which the data is going to be meaningful. So what is big data? So in the terms of big data, you can see the term big data refers to the data that is so large, fast, or complex that it's difficult or impossible to process using traditional methods. So the act of accessing and storing large amounts of information and analytics has been around a long time. So big data is a collection of data that is used in volume and get growing exponentially with time. So it is a data with so large size and complexity, and that none of traditional data management tools can store it or process it efficiently. So big data is also data but with huge size. So according to Gartner, you can see the big data is high volume, velocity, and variety. These three V's of big data. So volume means the data is voluminous. It means the data is in very large size. So you can see the data size from terabytes to exabytes of data to process, and the data is at rest. In other words, you can see the volume means the size of data, which plays a very crucial role in determining value out of data. So whether a particular data can actually be considered as big data or not is dependent upon the volume of data. So volume is one characteristic which needs to be considered while dealing with the big data. Then velocity. Velocity means the big data velocity deals with the speed at which data flows in from sources like business processes, application logs, networks, and social media sites, sensors, mobile devices, etc. So the flow of data is massive and continuous. So velocity means the data is in motion or speed of data. So streaming of data milliseconds to seconds to respond. And another V is variety. Variety of data means the data is in different forms. Means it is variety refers to heterogeneous sources and the nature of data. Means the data can be structured data or unstructured data. So variety of big data refers to structured, unstructured, and semi-structured data that is gathered from multiple sources. So data is many forms. Means the structured data you can see the structured data where the data is arranged in a tabular format, and the unstructured data refers to the data that lacks any specific form or structure whatsoever. So this makes it very difficult and time consuming to process and analyze unstructured data. So in addition to the size being huge, unstructured data poses multiple challenges in terms of its processing for deriving value out of it. Then the semi-structured data can contain both the forms of data. So the semi-structured data is in structured form, or but it is actually not defined with table definition. So the semi-structured data example, we can see the data represented in an XML file. So what are the sources of big data? So the various sources of big data are there: the images, cloud, the web is the source, IoT, and the database as a big data source. The another five V's of data, the three V's volume, we already discussed: volume, velocity, and variety. Another is veracity and value. So the veracity means the data is in doubt. So uncertainty due to data inconsistency and incompleteness. Ambiguities and latency deception, model approximations are there. And value means the data into money, means the data gives you some business models that associated with the data and produce some value. So in terms of money. So these are the various 5 V's of data: volume, velocity, variety, veracity, and value. Some more V's are also there. Visualization is there to visualize a large amount of complex data and like this. So we discussed already 5 V's. Then validity is there, means how you can validate the data. Variability is there, venue is there, and probability is there, and readiness is there. So these are the various V's of big data. Now this is the model of DIKW, where the data, information, knowledge, and wisdom is explaining this figure. You can see the data is just raw facts, where you can see this is the red color, or this is the this IP address, or this value is there. And the information there, the data is associated with some meaning, means for example, south facing traffic light on corner of it and George Street has turned red. So George will assume that he has to stop. Then knowledge means contact the traffic light I am driving towards has turned red, and the wisdom is applied, I better stop the car. So this is the DIKW model. The processor speed, and you can see the processor speed is increasing day by day. So first, processors are in very huge size, and the size of processors are decreasing day by day, and the speed of processor is increasing day by day. So you can see the mainframe computers are very large computers, then vector supercomputers are there, mini computer or workstations, then PCs, tablets, mobile phones, even you can do all the things in mobile. Massive parallel processing are there. So these are the various alternatives where you can see the data can be processed on various systems. So the cluster. Cluster is a type of parallel or distributed processing system which consists of a collection of interconnected standalone complete computers, and it is cooperatively working together as a single integrated computing resource. So this is single system image. You can see the various operating systems having various nodes are interconnected with each other on availability of infrastructure, and the single system image infrastructure is there, where programming environment can be provided by Java, C, Fortran, NPIP, and then virtual machine, or like any other programming language. And the web, Windows user interface can be provided, and other subsystems like database and OLTP, online transaction processing are there. So this is known as single system image. Then grid. Grid is the advanced form of cluster. Means the computational grid is a hardware and software infrastructure that provides dependable, consistent, pervasive, and inexpensive access to high-end computational capabilities. This definition is given in 1998 by Foster and Kesselman, and resource sharing and coordinated problem solving in dynamic and multi-institutional virtual organizations there. Means heterogeneous type of data can be solved by grid. Then 3-point checklist is there. So grid is a system that coordinates resources that are not subject to centralized control, and it is using standard, often general purpose protocols and interfaces, and to deliver non-trivial qualities of service. So comparison between grid and cluster computing is like this. When 2 or more computers are used together to solve a problem, it is called a computer cluster. And in grid, the grid computing makes use of several computers connected to solve a large problem. Cluster is homogeneous, while grids are heterogeneous, and cluster computers have the same hardware and operating system because it is homogeneous. And grid computers can run on different operating systems and can have different hardware and in heterogeneous network. So in cluster, machines are dedicated to work in single unit, while in grid it can make use of spare computing power on a desktop. And in cluster, computers in the cluster are normally contained in a single location or complex, and grid are inherently distributed by its nature over LAN, WAN, and WAN. And in cluster, resources are managed by centralized resource manager, while in grid, every node is autonomous. Then multi-core processors. So multi-core processor architecture entails clustering of two or more execution cores within a single processor chip. So you can see the operating system perceives each of its execution cores as a discrete logical processor with all the associated execution resources, and this multi-core processor plugs directly into a single processor socket. So the single core CPU chip includes the register file where arithmetic logical unit and register files are communicating with each other with the bus interface and through the system bus. So this is called a single core. So in multi-core CPU chip, the various cores are connected with each other. So core 1 having register file and ALU interconnected with core 2, core 3, core 5 through the bus interface. So this is the multi-core CPU. So why multi-core? So the doubling of transistors every couple of years has been maintained for 40 years. So if this rate continued, processors would surely be producing more heat per square centimeter than the surface of the sun, setting hard limits to frequency increases. So there are 16 or 32 or 64 and so on, so up to perhaps 256 processors cores on a single die. So the core principles are scale out rather than scale up, and bring code to data rather than data to code, and it deals with failures they are common, and abstract complexity of distributed and concurrent applications. Then scale out rather than scale up, so it is harder and more expensive to scale up.
No mobile deva.
So it adds additional resources to an existing node like CPU, RAM, and new units must be purchased if required resources cannot be added. So it is known as scale vertical. And scale out where the adding of more nodes or machines to an existing distributed application, and software layer is designed for node additions or removal, and Hadoop takes this approach. So it is very easy to scale down as well. So Hadoop is a tool where a set of nodes are bonded together in a single distributed system and to process the big data. So the bring code to data rather than data to code, where Hadoop cluster, where Hadoop nodes, you can see the storage and processor are having in each Hadoop node, and these are all interconnected with each other, so it is known as Hadoop cluster. So Hadoop co-locates processors and storage, and code is moved to data. The data size may be teeny or usually in kilobytes, and processors execute code and access underlying local storage. So Hadoop is designed to cope with node failure. So if a node fails, the master will detect that failure and reassign the work to a different node on the system. And restarting a task does not require communication with nodes working on other positions of the data. So if a failed node restarts, it is automatically added back to the system and assigned new task. And if a node appears to be running slowly, so the master can redundantly execute another instance of the same task. And results from the first to finish will be used. So Apache Hadoop, it is an open source using the Apache license, where around 44 Hadoop commuters from companies like Yahoo, Facebook, Apple, Cloudera, and more are using this Hadoop. And hundreds of contributors writing features, fixing bugs, and other ecosystem products. So this is the Hadoop ecosystem, where Hadoop distributed file system, it is at the lowest layer. Then YARN and MapReduce is for distributed processing framework. Uji is for workflow. Pig is for scripting. Scripting language. Pig Latin is used for Pig scripting. Mahout is for machine learning, and R connectors for statistics. And Hive is for SQL query, and HBase is columnar database to store the data, and the provisioning, managing, and monitoring Hadoop clusters through Ambari. And Zookeeper takes the coordination of all these layers, all these parts, and the Plume is the log collector, and Scoop is more data. So this is research periodic table. As you can see, in chemistry periodic table is there: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, like this. So this is research periodic table where M is for map reduce, H for Hadoop distributed file system, Y for yarn, like this, H for HB for the HBase, like this. Then Hadoop ecosystem, where for storage we are using Hadoop distributed file system, and unstructured or semi-structured data is used by Plume, and Scoop is used structured data in tabular format, and data is stored in Hadoop distributed file system, and the resource management through Yarn, yet another resource navigator, and Apache Ambari is for management and coordination, and HBase is NoSQL database, UB is for scheduling, and Disk is for scripting, SOLR and Fusion for searching indexing, Mahoof Spark library for machine learning, Hive and Drill for analytical SQL on Hadoop, and MapReduce for processing using different languages, and Spark is for in-memory data provision. It is about the Hadoop. So Hadoop ecosystem where these four parts are main: Hadoop distributed file system, Hadoop MapReduce, Hadoop Yarn, and HBase. So Hadoop distributed file system is used to provide high throughput access to application data and used to store the data. And Hadoop MapReduce, it is a distributed parallel data processing model and execution environment for handling large data sets. And Hadoop Yarn is a framework for job scheduling and cluster resource management. HBase is a scalable distributed column-oriented database that supports structured data storage for large tables. And Pig, it is a high-level data flow language and execution framework for parallel computation of large data sets. Hive is a distributed data warehouse query language based on SQL that provides data summarization and ad hoc querying. Cassandra is a scalable multi-master database with no single point of failure. Mahoof is a scalable machine learning and data mining library. Sequoia is a data collection system for managing large distributed systems. And another are Flume, Scoop, Uzi, Who, and Jupyter. So Flume is a distributed, reliable, available service for efficiently moving large amount of data as it is produced. Scoop is a tool for efficiently moving data between relational databases and Hadoop distributed file system. And Uzi is a tool to provide ways for developers to define an entire workflow. And Hue is graphical front end to developer and administrator functionality. And Zookeeper is a distributed, highly available coordination service. And Euro is a data serialization system, and Spark is a fast and general compute engine for Hadoop data supporting machine learning, stream processing, and graph computation. Somebody is a web-based tool for provisioning, managing, and monitoring Apache Hadoop clusters, which includes support for Hadoop distributed file system, MapReduce, Hive, HBase, Zookeeper, Uzi, Pig, and Scoop. So Hadoop distributed file system is mainly responsible for storing data on the cluster. So data files are split into blocks and distributed across multiple nodes in the cluster, and each block is replicated multiple times. So default is to replicate each block 3 times, and replica is stored on different nodes. So this ensures for the reliability and availability. So you can see in Hadoop distributed file system, the name node is there, and it stores the metadata only. So metadata like this: user Dyna 124, user Dynava 35. So you can see every block. These are the various data nodes, and it stores blocks from files. So every block is stored on 3 data nodes. So block 1 is at node 1, node 2, and node 4. Block 2 is on node 1, node 3, and node 5. Data node 5. And block 5 is on data node 2, data node 3, and data node 4. So like this. So 3 and 5, the example of 3 and 5 is given here. So block 3 is on data node 3 and 3, this one, and 4 and 6. So block 3 is on 3 data nodes. And block 5 is on data node 2, data node 3, and data node 4. So what is Hadoop daemons? So Hadoop is comprised of 5 separate daemons: name node, secondary name node, data node, job tracker, and task. So name node holds the metadata for SDFS, and the secondary name node performs housekeeping functions for the name node, and it is not a backup or hot standby for the name node. Data node stores actual SDFS data blocks, and job tracker manages MapReduce jobs, distributes individual tasks. And task tracker is responsible for instantiating and monitoring individual map and reduce tasks. So this is the 5 Hadoop daemons, how these are communicating. So the client sends jar and XML job tracker, and this is the name node where file location information can be stored. This is the master. And slave nodes consist of various data nodes where the task trackers are there, and there are map and reviews operations are there. So it reads and writes SDFS files and communicating with the user. So this is the Hadoop distributed file system where the metadata operations are there on Nemnode, and the metadata is stored in this Nemnode. The various block operations on various data nodes situated at various racks. So rack 1 having 3 data nodes, rack 2 having 2 data nodes, like this. So these are the various clients. So the write operation is there, the replication of data means every block of data is stored on 3 data nodes, and data is read by the client from these data nodes, and the metadata operations, everything can be managed by Nemnode. So this is the Hadoop distributed file system architecture. So you can see in Nemnode, it is the master daemon that maintains and manages the data node or slave node, and it records the metadata of all the files stored in the cluster, and the location of blocks stored, the size of the files, permissions, hierarchy. There are 2 files associated with this method, FS image and edit loop. So file system image, where complete state of the file system namespace since the start of the node is there, and edit loop, where all the recent modifications made to the file system with respect to the most recent file system image. And it records each change that takes place to the file system metadata. So these are the slave daemons, the data nodes are the slave daemons, or process which runs on each slave machine. So the actual data is stored on the data node. So the data node performs the low-level read and write request from the file system clients, and they send heartbeats to the name node periodically to report the overall health of Hadoop distributed file system. So by default, this frequency is set to 3 seconds. So the block replication is like this process. The file is there where it is made up of 64 MB blocks, and the various data nodes associated with this name node. So it is communicating with the blocks, are communicating with the various data nodes where the data is placed, and the file system image or edit log or in memory file system metadata, everything can be managed through this name node. So this is the block application. So you can see various nodes, data nodes are there, and the various blocks. So the blocks are defined here with various colors. So block 1 is having orange color. So block 1 is stored at node 1, node 2, and node 4. You can see block 3 is in green color, which is stored on data node 1, data node 3, and data node 4. And block 4 is in red color. It is on data node 1, it is data node 2, and data node 3. And block 5 is in blue color. It is on data node 1, data node 2, and data node 4. So Hadoop distributed file system read, file read is there. So Hadoop distributed file system client, where first step it is open for the connection for the distributed file system, and it gets locations in second step, and in third step it reads the file system data input stream, and in fourth step it reads the data from data nodes, in 4, 5 step, and in 6 step it is clear. So Hadoop distributed file system write operation is like this. First it is create, then on distributed file system, then create on name node, then it writes on file system data output stream, and then write packet, and then acknowledge packet, and at last step it is do. So the various data nodes are communicating with each other, and the acknowledge is given to the file system data output stream to Hadoop distributed system client. So Hadoop MapReduce, where MapReduce is a system you need to process in the Hadoop cluster. So there are 2 phases, map and reduce. So each map task operates on a discrete portion. One SDFS block of the overall data set, and MapReduce system distributes the intermediate data to nodes which perform the reduce block. So the Hadoop MapReduce, where map function input key is there, input value is there. For each word in input value, and it emit like this. The input key and value is given. So to input to the mapper, the key is like this 3414, and the input value is the cat set on the back. Another input value is 3437 key, and the value is the advert set on the sofa. So output from the mapper, so every word is associated with value 1. So you can see the 1, cat 1, set 1, on 1, the 1, mat 1. Then the 1, advert 1, set 1, on 1, the 1, and sofa 1. So the mapper input, we given these two sentences, and mapper output, every word is associated with value 1. Then add all the values associated with each intermediate key. So the reduce function where reducer input means advert comes one time, cat one time, mat one time, on two times, and set two times, sofa one time, and the four times. You can see the comes four times. The and the like this. So in reducer input, we combine all these things, means the comes four times. How many times the word comes? So we counted there in reducer output. So advert 1, cat 1, mat 1, on 2, set 2, sofa 1, and there comes four times, so the 4. So the mapper input is there, mapping, then suppling, where how much times the word comes, we are combinedly associated with in a single unit, means the 1111 like this. Then in reducing phase, it is reduced, and how much the total count is there. So the p value will be the total count of the words, and the final result is advert 1, cat 1, mat 1, on 2 times, set 2 times, sofa 1 time, and the 4. So this is the Hadoop map reduce, where preloaded local input data is there, then intermediate data from mappers are there, then values exchanged by shuffle processes, and it reduces processes and generates output to reducing process like node 1 from node 2, node 3, and the output is stored locally. So this is all about the general big data. I am happy to share any queries.
Yeah, dear participants,
Yes,
if you have any queries.
any doubt or any query, I am happy to give the answer. Okay, let us see. I already discussed about big data. So, what are the various examples of big data? You can see the like black box data. So, what is black box data? So, it is component of helicopters, airplanes, and jets, etc. It captures voices on the flight crew, recordings of microphones and earphones, and the performance information of the aircraft. The social media data. It is another example of the data. So social media, like such as Facebook and Twitter, hold information and views posted by millions of people across the globe. So it is the example of big data. Another example of big data we can take the stock exchange data. So the stock exchange data holds information about the buy and sell decisions made on a share of different companies made by the customer. So another example of big data we can take power grid data. The power grid data holds information consumed by a particular node and with respect to base station. So it is another example of big data. You can take another example of big data is transport data. So in the transport data, it includes modal, capacity, the distance of traveling, and the availability of a vehicle. So the transport data, it is also example of big data. Another example of big data is search engine data, where search engine retrieves lots of data from different databases. So the big data is high volume, velocity, and variety information assets that demand cost-effective, innovative form of information processing for enhanced insight and decision making. So the difference between traditional data and big data. So just I am telling you the difference between the traditional data or small data and big data. So the traditional data, it is a very it is small data. Big data, it is mainly the in volume. It is large in volume. the traditional data mostly deal with structured data, means it is deals only with tabular format of data. But big data, it can be deal with structured, unstructured, as well as semi-structured data. Every data can be handled with this big data. So the traditional data stores in megabyte, gigabyte, or terabyte, but the big data can be stored in various petabytes or exabytes, zettabytes like this. And the traditional data increases gradually, but the big data increases exponentially. The traditional data can be locally present and the big data globally present distributed. The traditional data can be stored or can be processed with SQL, structured query language, or Oracle, and the big data can be processed with Hadoop and Spark like tools. And the traditional data is like only single node cluster, and in big data we use multi-node cluster as we already discussed. So, what are the various types of data? So, the various types of our data are structured data, unstructured data, and semi-structured data. So, structured data means the data that can be processed, stored, and retrieved in a fixed format. So, it refers to highly organized information that can be readily and seamlessly stored and accessed from a database by simple search engine algorithms. So, for instance, the employee table in a company database will be stored as the employee detail, their job positions, their salaries, etc. That can be organized in a tabular format. So, this is the example of structured data. So, an employee table in a database is an example of structured data, where employee ID is there, employee name is there, employee department is there, employee salary is there. Then unstructured data. Unstructured data refers to the data that lacks any specific form or structure whatsoever. Means this makes it very difficult and time consuming to process and analyze unstructured data. So in addition to the size being huge, unstructured data poses multiple challenges in terms of its processing or deriving value out of it. Unstructured data like we take example email or Google search are the examples of unstructured data, because a typical example of unstructured data is a heterogeneous data source containing a combination of simple text file. So you can include some text in email, you can include some picture in email, any PDF like text file, image, video like this. So this is heterogeneous data or unstructured data. So nowadays, organizations have wealth of data available with them, but unfortunately, they don't know how to derive value out of it. So since this data is in its raw form or unstructured format, so this is unstructured data. Next is semi-structured data. The third type of data is semi-structured data. So semi-structured data is lies between structured and unstructured data. Means the semi-structured data can contain both the forms of data. So we can see semi-structured data as a structured in form, but it is actually not defined with like table definition in relational database management system, or example of semi-structured data is a data represented in an XML file. So these are the various types of data can be handled by big data. And in order to achieve the success with big data, it is important that companies have the know-how to shift between the various data sources available and accordingly classify its usability and relevance. So media as a big data, it is a source where images, video, Facebook, Twitter, YouTube, etc. Can be used as media as big data. And cloud is a big data where everything can be used or can be stored on the cloud. And where is a big data, means where is a source, or this is the source of big data, and IoT is a big data source, and the database is a big data source. So these are the various sources of big data. And if you have any query regarding this, I am happy to solve or happy to answer.
Thank you, Dr. Pankaj. Participants, if you wish to interact with the resource person, you can please unmute yourself and you can interact.
Sir, myself Dr. Anand Mohan.
Yes.
I'm attending this presentation from LQ. Okay, so I just have a query. How does this big data analysis can solve the problem in gene sequencing and analyzing of DNA data?
Which problem, sir?
There are many alignment problems occurring when we are doing the sequencing of DNA, gene sequencing. So is there any way that this big data can help us in solving that problem?
Yes, sir. You can see the various problems associated with data. So in gene sequencing, you can see it is type of various analysis like multi-terabyte data sets, or you can simply many of the synthetic biology procedures involve huge chunk of data, including but not limited to sequencing. So the artificial sequencing such as biobricks and expanded generic codes, etc., involve analysis of huge data. So this can be done with gene sequencing and involve analysis of huge data sets, as it involves some of the procedures like at a genotypic level and the data related to its expression, like combining these two and the data becomes huge. So the genotype and data can be used with various combining these data and with the huge data sets it involves in analysis. Yes, sir. Any other
Yes, sir.
query?
Yeah. Thank you, sir. Thank you very much, sir.
Participants, if you wish to interact with the professor, you can just unmute yourself and you can interact. Sunil will proceed, sir. I will thank the professor and Sunil, sir.
Yes, sir. Sir, am I audible?
You're audible, sir, please.
Yes, sir. Sir, Pankaj sir, thank you so much for giving your valuable insights on big data and Hadoop. You, within a short span of time, you covered many of the topics like uh, what is Hadoop ecosystem and what are its parts, and Hadoop demands, and you already explained about the architecture, what is the name node, and how the client is work, and you also explained the functions of data node clearly. I don't know how much time you spend for creating this image of blocks of replication. You design all the blocks, and clearly you explained about you treated all our participants as a students, and you explained in a clean and a neat manner, sir, and how the file is going to be read with a sample code of Hadoop map reduce also you explain, sir. Really, we are thankful to you to have such a great person as a resource person in this faculty development program, sir. From Department of CSC, Sri Vishnu Engineering College for Women, we thank you for joining with us. We are
Thank you,
grateful to
sir.
you, sir.
Thank you, sir. Thanks a lot.
Thank you, and Dr. Pankaj, it's a privilege listening to you online. Hope you will collaborate in future.
Thank you, Professor.
Thank you, Dr. Pankaj. Have a
Thanks
nice
a
day.
lot for giving this opportunity.
Yes. Dr. Jayashree.
Yeah, yes, sir.